All right. Okay, if we want to know what this motion looks like as a function of time, we can plot position as a function of omega t. The reason I'm doing omega t is because that's the full argument of cosine. So we can scale it by pi, 2 pi, and stuff. All right, so at time equals 0, we have our mass here, and we've stretched it the full distance a. And so you can see by that pink line of the plot there, that seems to agree pretty well. Now, when omega t is pi over 2, if you plug in pi over 2 into the cosine of the angle, you're going to get what? 0, which makes sense. In this placement, you're back at the unstretched of the spring. And now when you're at pi, you fully compress the spring. You're at your maximum negative displacement. So you're at negative a. And then so on at 3 pi over 2, 2 pi. It's going to repeat this motion over and over again. It's going to go back and forth. But now let's look at the velocity. Let's just make sure these equations actually make sense. So at time equals 0, it's saying that I have 0 velocity. So let's see, that makes sense. If I pull my spring back, right when I'm about to let go, how fast is it going? Let's say pull back this way, because I define positive spring that way. All right, now once I let go of it, which way is it going to go? That way. Which way is positive x? That way. So it should be negative, right? All right, so that seems to make sense. Now let's look at the acceleration. When I first pull it back, which way is it going to accelerate? Negative. So remember, force equals ma, right? So maximum, when I have it stretched to its max, we should have the most force, so when I let go, it should have the most acceleration. So that seems to make sense. All right. Now, let's imagine that little thing phi naught. Let's imagine that it's not 0. So what does it do? Well, you can see, look at the plot here. All that it really does is it looks like it shifted your axes over a little bit. It makes it look like you got a little bit of a head start over a cosine that maybe had a phi naught of equal to 0. But if you look at some point later in time, you see that they all line up in the exact same way as the previous slide when our phi naught was equal to 0. So really, after things have been oscillating for a while, it doesn't change the behavior, it just changes the starting point.